Thank you for coming. This is Testing LiveView. My name is Velasco, and I work at ThoughtBot. We're a group of developers and designers who love to help companies identify and solve problems, and we love working with Elixir. So if that's something that interests you, please let me know. Before I even get started, I just want to thank all the contributors who've contributed to LiveView Test. It's been a true pleasure to work with it, honestly, test driving applications with it, and just working it in general. It's been such a joy. So I know there's even more people who've contributed to LiveView, but this is just the LiveView test module itself, and just thank you so much. All right, I want to talk about how to write effective tests, and I like to learn by doing. So we'll be writing tests for a to-do application. Along the way, I hope to learn how to write LiveView tests. So if you don't have any experience with writing LiveView tests, that's perfect. That's okay. And then we want to talk a little bit about testing the right things. And then finally, I want to learn how to write explicit tests, or tests that are clear and understandable, or really in the language of our time, to achieve some type of enlightenment. Just as a side note, I'll be using version 0.14.4 of LiveView, since it's a fast-moving library. That's just worth noting. Now, let's take a quick look at the to-do that we'll be testing, right? The to-do app. So we can add to-dos. We want to click on them. We want to be able to add some notes to them. We're deciding the fate of the ring, and it can't be destroyed by an axe. We have to cast it to Mount Doom. But then we can also sort the to-dos and, of course, complete them. And so this is, a to-do app is the domain is understandable, so it'll help us focus on the tests. Let's get started with how to write LiveView tests. You define a module test like any other one, and we'll use two things. First, we'll use the con case. And if you are familiar with controller tests, this is the same thing, right? And we'll need a connection struct because we want to mount the LiveView, and we'll see that in a second. The second thing we'll use is we'll import Phoenix LiveView test, and will bring all the helpers that we need. Okay, let's talk about the anatomy of a test. Roughly speaking, what will we see? And I'll talk about each of these groups in detail in a second. We'll just kind of go over the whole anatomy. So we'll usually be mounting the LiveView, grabbing that view, targeting an element on the page, right? In this case, we're targeting a list item, for example, and then we're going to perform an action on that element. In this case, we're going to click on it, and then we can expect the render text. We can assert some truths about what that's rendered, or we can actually assert some truths about the view and an element in that view, and that's what this has element is doing here. Let's talk about each of these in turn. So let's talk about the live helper. The live helper takes in a connection struct, which is why we need that con case, and then it also takes a path. Now, it's doing a lot of heavy lifting for us under the hood. You see it returns a 3 tuple. And let's talk about the HTML part first, right? So what live helper is doing, it's following LiveView's life cycle. So just like LiveView we need a HTTP request first, a stateless request, and then we mount the LiveView. Well, in the same way, this live helper will make the HTTP request first. So just like in a controller test, you could write a test like grab the connection struct, make a get request at a particular path, parse the HTML response with, say, like a 200, and grab that response and assert things about the static response. Well, that's the same thing this HTML is. So you can assert truths about the disconnected state of this LiveView rendering. But we could also get access to the actual view, the mounted view, the connected state. And that's what this second element is, that view. And so we can render that view and assert truths about that. Now, as a note, this live helper is only for LiveViews that are mounted via the router. If you're mounting your LiveViews via a view or a controller, you can use a live isolated helper that will return the same 3 tuple. Okay, let's look at the functions that I call scoping functions. They're element and form, and we'll look at form in a second. They take in a view, a CSS selector, and the element takes an optional text filter. Now, if you're familiar with Ecto, for example, you might be familiar with the distinction between queries and the repo, right? The queries are a representation of what we're going to actually perform in the database. The repo actually performs the action. In the same way, this element scoping function isn't really doing anything. It isn't performing an action against the page. It's just a description of what you're trying to find. So it'll build an element struct with a CSS selector and an optional text filter. The form acts in a very similar way. So you pass in a CSS selector, and instead of a text filter, you pass in form data. Now, a note about these CSS selectors, they have to target an element uniquely on the page. So you can't pass in a CSS selector that would return a list of elements. That's just something to keep in mind. So this form function will actually also return an element struct, or it builds an element struct with the CSS selector and the form data. Now, I've been saying CSS selectors, the usual suspects apply, right? You can use classes, IDs, tags, data attributes, all those kinds of things. And I actually use several of them throughout the examples. Let's look at the what I call action functions now. There's many of them, and we won't be using all of them throughout these tests, but you can see there's blur, change, render, click, render, focus, key down, key up, submit. You also have render hook and render patch kind of functions. The thing I want you to notice about them is that they have two versions, right? A 2-argument and 3-argument variants. And the distinction there is that you can either take a view or take an element, like a scoped element, like we've been talking about. And I'll talk in a little bit about why I think one might make more sense over the other. Finally, we can take, let's talk about assertions, right? So each of these actions that we call render star will return the render text. And so you can assert some truths about that. Or you can also use this has element helper that takes in a view, a CSS selector, and an optional text filter. And so this lets you scope like assertions to a particular portion of the page. So I find it really helpful. Okay, let's jump into some examples. Adding a new to-do, right? So we're going to test this. We want to be able to type in a new to-do in an input, and it shows up in the list of to-dos, right? The description, user can add a new to-do. We're taking that connection struct. Once again, that's why we need the con case. We're going to mount the live view at a particular path. And notice we're ignoring the HTML because we're not going to worry about the disconnected state. We want to interact with the live view. We're going to target a form based on an ID. So this new to-do is the ID in the form. And then we're going to pass in the form data, right? This to-do, we want to put in some text, and the text is the site fate of ring. And then we're going to submit that form. Finally, we're going to grab that view, and we're going to make sure that in the to-dos, there's a decide fate of ring to-do, right? Now, because this is the first test we're writing, I want to talk about 2 alternatives of how we could have written that test. One is we could have used the render submit 3 without the form scoping, so taking the view directly. And the other thing is that we could have assert against the render text. Let's look at each in turn. First, instead of using this form helper, right, the form scoping that I called it, we could have just targeted the event directly. So we could have render submit, pass in the view, the event itself, create to do, and pass in the payload. Now, the downside of this is that it targets this handle event directly, right? So you can, in fact, delete the entire form from your HTML, and the test would still pass, right? So that's a huge false positive. In contrast, if we use this form helper, the combination of the form helper plus the render submit will make sure that for this particular ID, the element that has this ID, the element that we've targeted with our CSS selectors, actually has a Phoenix submit attribute attached to it. And it'll also try to match the form data against the form on the page. So my advice is, in general, try to avoid targeting events directly. Let's look at the second thing we could have done differently. When we render submit, we get some text back. So instead of using our has element helper, we could have just asserted some text against that render text. Now, that works a lot of times, and I think it's actually a really good usage, but there are some times where we want to be more careful. In this case, we want to make sure we're finding the text for the to-dos, right, in the right to-do. We want to avoid the scenario where our form submission failed and the page that rendered still has that text. It's just not in the place we think it is, right? So my advice, even though it's a little bit more verbose, is to use the has element helper in assertions. So this is what I would call my canonical example of a LiveView test. Let's look at another example that will involve testing a to-do component or a live component, right? So we want to show a to-do's details. When we click on a to-do, we want to show this little panel with the text and the notes that we have for the to-do detail. That panel will be a live component. So once again, we declare the test. Selecting a to-do opens the to-do details panel. We're going to create a to-do. How you create it doesn't matter. You could use Ex Machina. You could create it, however you want, but this is in our database. And then we're going to mount the live view. We'll grab the view. We target a to-do based on its ID. And we're going to target the text itself, right? That's why we're passing that text filter. And we're going to click on that text. And then we want to make sure that in our view, we have this like details panel open. So we're looking for an ID with to-do, the to-do's ID, and the details. Now, we're only testing the behavior from LiveView's perspective here. We're not making assertions about the component itself. I like to test that in the component test because that's its responsibility. So let's look at a component test really quick. We're going to use the same kind of setup. We're going to use concase and LiveView test. Technically speaking, we don't need concase for this particular test we're looking at right now because we're only testing static parts. But we'll see in a second why we need it later. So let's write this test. We want to render a to-do with nodes. This is, remember, just testing the component itself. So we create the to-do, and we use this render component helper. It takes a component name and the set of assigns. So this is very similar to how you might actually render the component in LiveView. And this returns the static HTML, right? So we can make assertions about the text that we expect to see there. Now notice that this render component doesn't have a way to test interactivity with the component itself. So in order to test interactivity, we'll actually have to use the live helper, mount the live view, and find the component on the page, right? So that's why we need the concase sometimes. Okay, so that's a super brief overview of how to write tests. But we want to make sure we're testing the right things. Let's take a look at another example. We want to mark to-dos as complete, right? So when we click on them, they become this sort of scratched out version of the to-do. A user can mark a to-do as complete. We grab in the connection struct again. We're going to create a to-do, and we're going to mount the live view. We're going to target that to-do's input based on the to-do's ID, and we're trying to find that little checkbox, right? And then we're going to click on it. And what should we expect? We expect that to-do, so that text, to be scratched out. And that's what we're doing here. And this test works fine. But sometimes what I've seen is people might want to do this. They might want to assert that this action that we performed goes all the way to the database, right? That they get the to-do from the repo to get an updated version of it and check that it's been completed. Now, I think of this as a code smell because LiveView is fundamentally about the UI. So we want to test UI interactions, not things against the database. Or another way to put it is we want to write tests from the perspective of the user, right? So what I would do is keep the test this way, right? Just make sure that you write assertions about what the user can see. Now you might say, okay, but how do we test this logic? And I think this is a good point, right? Perhaps our handle event function is doing the updating of the to-do in there. And so you say, well, I want to test this, but if you say I shouldn't test it on the LiveView test, where should I test this? I think the urge to test this is itself a sign to us, and we should listen to it. So we should listen to your tests for signs of coupling. I think what it's telling us is that our test is telling us that because we want to test the database persistence, is that LiveView is doing too many things. It has too many responsibilities. So what I would urge you to do instead is to extract this logic into, say, like a to-dos module. And in that to-dos module, we test that behavior, that responsibility, while keeping the LiveView tests to test the LiveView's responsibilities. Okay, let's take a look at another example. Say we want to change how to show a to-do's details, right? So we already know that when we click on a to-do, it opens up this little details panel. But right now, our implementation is using a Phoenix click attribute. When we click on it, we grab that to-do's ID, and we use that as the current to-do that's been selected. And so once we have that selected to-do, we render the component, the live component for that to-do. What if we want to change that to a live patch, right? Where instead of, so we would use the handle params callback to define what's the current to-do, and that way we display the right component. The question for our perspective of tests is, should we change this test from asserting that we have this element on the page to asserting that we've patched the view correctly? Right, so this is a reminder. This is a test where it's making sure that selecting a to-do opens the to-do details panel, right? Or maybe put differently, what if your original implementation had been about using live patch? Should you write this assert patched as opposed to something like this has element helper? I like to take a step back when I find myself in these situations and ask myself, what does the user see, right? Let's see, the existing behavior is that clicking on the to-do's text opens a details panel. The new behavior is that clicking on the to-do's text opens a details panel. And that's not a mistake, right? The behavior hasn't changed. So my advice is, again, test behavior, not implementation. In this case, our user doesn't see any behavior change, so our test is unchanged, right? You might say, well, I want to make sure that I can share a URL and visit that to-do in that state. And I think that's fine if you want to write a test for that in that scenario. Okay, let's talk about writing explicit tests. Our tests, we've learned how to write LiveView tests, and our tests are getting pretty good if we test behavior, not implementation, if we're testing from the perspective of the user. But we also want to make sure our tests are clear and understandable. And that's what this section is about. Let's look at an example of adding notes to a to-do. This is going to be our most difficult or longest example yet. Let's look at what we're doing. So we want to click on a to-do, be able to click on that edit notes and add some notes to it, right? Once we add those notes, and notice this is all being handled in the component, and then we update those notes, right? Once we add notes to a to-do, we also want to render this little notes icon. So that's just something to keep in mind. Okay, so let's look at this test. It's going to be a long one. A user can edit notes. We take in the connection struct. We're going to create a to-do without notes. And these are the notes we're going to add to it in a second. We're going to mount the live view. And now let's look at sort of subgroups of actions we're taking on that page. We're going to open the to-do details, right? We've done this before where we target a to-do's text based on its ID and the text, and we click on it. That'll open up the details panel for us. What do we want to do then? We want to click on that edit notes, right? So we're targeting the to-do details panel, and we click on the edit notes, and we expect that to change that component into an input where we can add the notes. So we want to target that form. Again, we're targeting that to-do details, and we pass in the form data, right? And then we're going to submit that. Finally, we want to assert that in that to-do details component, we have these notes now present. And then we want to make sure that that little icon shows up next to the to-do. Now this is this test is good, but it's a little bit big and it's hard to read. And I want you to think about it from the perspective of your coworker who's never seen this before, right? They may understand the domain. They may say, understand how the to-do app works, and they may have even seen the behavior, how it works. But if you look at this test with fresh eyes, it's hard to understand. It's hard to read. It's dense. So what can we do? Well, you might say, okay, well, I see you wrote comments there, and that's helpful. But I actually think comments are a little bit of a code smell, right? They hint at a lack of clarity on the test. That's why I had to write them in the first place. So this is where we can reach our next level of enlightenment. We want to write tests in the domain of our applications, right? So let's look at an example here, right? So this is the test, and we're going to extract each of these chunks of work into separate functions. Let's look at opening to-do details. Let's extract that into a function that declares the intent very clearly. So we grab the view, and now we call open to-do details, and we pass in the to-do. Notice we've just moved in the text, or sorry, the behavior, the logic in there, and we're returning a view because we want to make this into a nice pipeline. Now, opening editable notes. In the domain of our application, this is just really edit notes. So let's do that, right? Let's call it edit notes. Once again, we extract that to a private function, and all we're doing is returning the view so we can keep the pipeline going. We do the same thing with adding notes, right? The stakeholders or our users don't care that it's a form. We just want to call add notes, and so we just do that. We call it an add notes function. We return the view. What about our assertions? We could do something similar where we pipe into a function that says something like assert to-do details has notes or something like that, right? But I actually like this has element helper, and I like how this reads, and I like that it lets us separate sort of the actions in our tests from the assertions. So what is the confusing part here? The confusing part is really the CSS selectors. So I would argue let's extract those into things that are very descriptive, right? So we can do that. Let's assert that the has element in this view in the to-do details has notes. Likewise, we want to assert that the view has an element that has a to-do notes icon for this particular to-do, right? So I actually think this test is far more clear than our original test that we had. And in fact, I think this is a test that almost all your stakeholders could read, whether they be developers or not. And I think that's the point of these UI tests. You want to be able to write them in a way that your stakeholders can read them, right? So we visit the to-do path, we open the to-do details, we edit those notes, and we add some notes. And then we just make sure that in the details, we have these notes and we have that notes icon, right? So I think that gives us that level of enlightenment, if you will, right? So if I can get you to get one takeaway from the talk is this, that I think in order to write effective LiveView tests, we want to write tests from the perspective of the user, testing behaviors, not implementations of how we're doing things, and in the domain of our application. If you enjoy this, I've been writing a test-driven development with Phoenix book. It's freely available on tddphoenix.com. It's still a work in progress, but it's probably 70% there. And if you have any comments, questions, suggestions, or anything like that, I'd love to hear it. I'm Germsville in Twitter. Thank you. Let me check if there's...
Hey, thank you so much, Herman. Yeah, we have a couple of questions, so if
Awesome.
you could.
Thank you. Sorry, let me, gotta look at them here.
Yeah, no worries.
Does open to-do details mutate the view? Does open to-do details mutate the view? Let me try to remember the open to-do details. It does not mutate the view in the sense, well, right. I see. I think I understand where the question is coming from. Can you still see my slides, Andre?
Oh, yeah.
Okay, thank you. Awesome. Yeah, so it's probably asking about this, right, where you open the view to-do details. Let's go back quickly. Because we're rendering the view, is it mutating it? And that's a great question. We can safely, I think that's what the question is asking. Sorry if this is not the right question. But it is, we can safely return the view because when we use the assert has element or when we pipe into the view, the view is using a proxy underneath the hood. So it's fine. So in that sense, it is mutating the view, and that's why you can do this. Like, you don't need to return the same view, if that makes sense, because the render click is just going to render text. So we don't have like a transformed view that would have like the new data structure. So I think that's where the question is going. So in that sense, yes, it mutates the view in that sense, which is why you can return the view and use that in the pipeline, right, into the next steps. Let's see, the next question was, I was playing around with render hook function, and when passing in a view, it appears as if the view that's passed is a pseudo mutated in the test context. And there's some, sorry, there's some text here or some code, so it's kind of hard to spell it out. It says, okay, view HTML, live, build the connection, and render hook. View the inspect now reflects the state change even without any explicit reassignment. Any insight into what's going on here? This is a hard, I'm not sure I understand the question fully. But I think what it's saying is, is passing pseudo mutated in the text context. I would encourage this person to reach out to me. I'd love to chat more about this. I'm not sure I understand the question. It's about whether it's mutating the view and the hook. And when I've tested hooks, by the way, I use the same kind of scoping, by the way, because if you scope your render hook action to an element, it'll make sure that you have the like Phoenix hook attribute attached to it and all that stuff. But I'm not sure I understand the question, so I apologize for that. If you can reach out to me in Twitter or Slack, Germsville there as well in like the Elixir Slack. There's another question. How does LiveView testing library different from Wallaby? Thanks for the question. I think well, for starters, they're very different underneath the hood, right? So Wallaby or Hound, they use a Chrome, like something like Chrome driver, a headless driver, headless browser underneath the hood. And so you can test far more interactivity with like JavaScript and stuff like that. With LiveView test, you can't do any of that. There is a proxy that's acting as the process, it's sending messages and stuff like that. That's acting as the client, but you can't test JavaScript. When you render hooks, for example, when you test hooks, you can only test from sort of the boundary into the Elixir application. So, you don't have sort of apples to apples there. It is true. What I will say is that if you can use Phoenix LiveView test for testing, like if you have a lot of UI tests that involve Phoenix LiveView, I would prefer it over Wallaby or Hound. I just found it to be much faster. And it's surprisingly less brittle, right? Even though you don't have like even though you're not interacting with a true browser, it is less brittle, especially when you're dealing with JavaScript. Of course, like I said, there are limitations in that you can't test actual JavaScript code interactions sort of like fully end to end. So there's trade-offs. If you can get away with it, I would use the Phoenix LiveView test just because it's much faster. Do you have any recommendations to making the test more unitary, like passing a mock context, like you did with the to-dos module? That is a good question. I don't know that I would always recommend that. I'm not afraid. In other words, I'm not afraid of the the LiveView test being a little bit integration-y, in the sense that if the to-dos module, like I didn't mock out the to-dos module, for example, in that example, I simply let it do what it needed to do. And so the LiveView test is acting a little bit like an integration test, but it doesn't care about the responsibilities of the to-dos module. That's really, it's not so much that I don't want to exercise that code. It's really that where do we divide the responsibilities of what needs to be tested? So LiveView test the responsibilities of LiveView. The rest of the logic should be somewhere else, and that, you know, we test that kind of logic elsewhere. If you like mocks, or if you want to introduce a mock, I think that's fine. I have used mocks before, MOX, right? And that's a really great library. Could wow, the questions keep coming in. Thanks for the questions, by the way. This is great. Could the notes icon presence be tested in a different test instead of when adding notes, like the rendering of a to-do item? That's a great question. You could test it that way. I think I just tested it there because that's where the behavior was. So when I was adding notes, I wanted to make sure that that little notes icon was present there. But it's true that you could just test that, you know, on the initial render, that if you render a to-do with notes in it, you have a notes icon. That's a great point. That would probably be easier to test, frankly. And so you could test it that way. Yeah. I think that's all the questions. And if anybody has other questions, and you know, or you don't think about them right now, really feel free to reach out in Twitter. My DMs are open, so that's also a good way to reach me.
Awesome, Herman. Well, yeah, that's all the questions that we got. So, oh, we have one last question. Do you want to answer that?
I have not gotten it. Oh, there you go. In your TDD training tutorial, is there a chance you'll use and explain LiveView testing? Oh, thanks. Great question. Yeah, that is part of my idea. The TDD test-driven Phoenix, I think that's what the question is about, this website. I built most of it before LiveView came out. So, or, you know, when I built the application that I sort of run through in that example. But my hope is to at some point go back and update it to, like, not some point, but it's in the plans. The plans is to kind of finish this, the book, sort of the writing of it, then go through the application again, and then whether it's a sort of an addendum at the end, or whether I make it to a different chapter of something like refactoring the chat application to use LiveView. My aim is to hopefully use that there and introduce it. So I hope so. It's a lot of work, but I really hope so. Yeah.
Great. Well, I think that's enough for the questions. I really appreciate joining ElixirConf. Thank you so much, Herman. And well, see you around in the other talks.
Awesome. Thanks so much.
Thank you.